Hi, it's time for another math easy solution to discuss further into integration of rational functions by partial fractions, and now go over example 5 of the example series and basically solve this example, which is integral of 2x squared minus x plus 4 all divided by x cubed plus 4x dx. So now the first thing to notice with this rational function is the numerator and denominators, the degrees of them. So the top one has the highest degree of x squared, and the bottom is, well, degree of x cubed right here. And so this is a proper fraction because the denominator at the bottom is bigger than the denominator at the top. So we don't need to use polynomial long division. So now we just have to, well, break this apart using partial fraction decomposition. So if we write this fraction out and try to reduce or factor out this denominator, we get, well, an x. Take the x out, now we have an x squared plus 4 right here. And now, as you can see, this part right here, this is non-linear, and we can't reduce it anymore. So it's non-reducible, so we can't simplify it any more than it already is. Reducible. So now because of this, we have to use, well, the technique that I showed and proved in my earlier, which I just showed and actually proved, but in my earlier video on partial fraction decomposition. So make sure to watch that in the link below. So basically this would equal to, using partial fractions, a over x, which is this factor, and then we need to add a linear factor right here, a linear coefficient, or in the numerator, bx plus c. And basically now we have this non-linear x squared plus 4. So we need to do this, and I explained why in my earlier video, so make sure to watch that in the video links below. So now we just have to solve well for a, b, and c. And now what we do is multiply both sides by x times x squared plus 4, and we get, well, 2x squared minus x plus 4 equals 2a times x plus 4, because the x's cancel. Now this right here, bx plus c times by x right here. So now now we have to solve these in a quick way to get this a1 here. Well, we just let x equals to 0. So at x equals to 0, we cancels all this bx plus c and all this. We get 4 equals to a, well, times 4. So we get a equals to 1, just cancel the 4's. So now that's the first coefficient. And now if we expand these out, so what we could do is expand these out. 2x plus 4 equals to, well, this is a 1, so this is x squared plus 4 plus px squared plus cx right here. And now combine the like terms, so we have right here b plus 1 times by x squared, and now plus cx plus 4. And now basically, if these are equal, the coefficients in front of the x squared right here needs to equal this term right here too. And this c has to equal to, well, right here, it has to equal to this part, and then this 4 is just equal to this 4. Yeah, so, and that's already there, that's already true. So this part needs to equal to 2, so b plus 1 equals to 2. Simplify this, move this over, b equals to 1. And now the last one, the c, c has to, well, equal to negative 1, which is in front of this right here. So there's our 3 terms right there. Yeah, so now if we combine all of these, we get basically the integral of 2x squared minus x plus 4 over x cubed plus 4x. And then dx right here equals to the integral now of, well, a over x, which is just 1 over x. 1 over x plus, now we have b, which is just 1, minus c, which is, plus c, which is negative 1, x squared plus 4 dx right here. And now this part right here, if we expand this out further to help it solve it, so we get, well, integral of 1 over x plus now x over x squared plus 4 minus 1x squared plus 4 dx right here. So now we have three of these three of these terms, and we can integrate them individually. Well, we know the integral of 1 over x dx, this just equals 2. Well, generally this is just ln absolute value of x plus c. So that's what this one is. And now for the second one, that's the tricky one right here, x over x squared plus 4. So there's no formula for this that I know of, so one way to do this is to basically let u equals 2x squared plus 4, and the reason for this is because du, or derivative here, is 2x, dx right here. And then this part right here, x dx, that's this part right here. So x dx equals to du over 2. Now we can replace this whole thing. So this equals to integral of du over 2. So 1 over 2 du, over u. And now this equals 2. Yeah, now this equals 2, just 1 over 2 ln of, absolute value of u plus another constant right here. We'll call this, this is c1, this is c2. So that's c2 right there, and then this ln u, when we plug it back in, which is x squared plus 4, this is 1 over 2 ln, and now you don't need the absolute value because x squared is always positive, x squared plus 4 is always positive, plus constant 2, so just to put the constant just for completeness. So now we have the second term, so that's the derivative of that one, and now this last part, this one's a bit tricky, and this is basically integral of 1 over x squared plus 4 dx. Now in solving this, recall my earlier video of the derivative of basically d over dx of inverse tan of x right here. This equals to 1 over x squared plus 1. So if that equals that, what we could do now here is just check out what the derivative of tan inverse of x over a right here. Yeah, now this one here, if you solve this is just 1 over x over a squared plus 1. Then using chain rule, this is going to be derivative of the inside x over a, that's just going to be 1 over a. And now expand this out, this equals to 1 over x squared over a squared plus 1 times it by 1 over a. So we get this, multiply now this bottom here by a squared divided by a squared. So multiply this a squared inside, we get basically this a squareds cancel, and this brings it up because it's 1 divided by, so we have an a squared on top, now an x squared plus a squared. This a squared cancels with this one, times by 1 over a right here, and then just cancel these out. This just equals 2a over x squared plus a squared. And now if we want to divide both sides by, this is going to be d over dx of tan x over a. Divide this a out, so we get basically d over dx 1 over a of tan inverse tan of x over a equals to 1 over x squared plus a squared. So now the reason we have this, so if we look at the integral now, integral of 1 over x squared plus a squared dx, this equals to, this is just going to be now 1 over a tan of x over a, and again plus a constant, we'll just say it's c3 or whatever, c3. And now, so now if we add our now if we add our 2 here, because this is x squared plus a squared, but we're trying to solve it for x squared plus 4, which is 2 squared. So this one right here, x squared plus 4 dx integral is going to equal to 1 over 2 tan inverse tan x over 2, and then plus, c, I'll just put this as a c. This is just for general formula, c3. So now that we have all of this together, put these all together, we have the integral of 2x, let's block this out, minus x plus 4, all divided by x cubed plus 4x dx equals to, well, yeah, equals to the first term plus a second, and then subtract the third, which is ln absolute value of x, which is right here. Then we have a 1 over 2 ln x plus 4. Then we have the last one, 1 over 2 inverse tan of x, x over 2. So this is going to be ln absolute value of x plus 1 over 2 and ln x squared plus 4, and then subtracted by 1 over 2 inverse tan of x over 2, and then plus a constant. I'll just say k. This is the addition of all these 1, 2, 3, so I'll just put constant k right there for completeness. And this is basically the answer. And here I've just circled it around. Anyway, that's all for today. If you learned from this extensive example, and I'll go over another video, which is just to put this in its own place, the derivative of this, or the integral of 1 over x squared plus a squared, just so you could use that for reference. For later examples that I'll do, that I'll use this formula. Anyways, all for today. If you learned, like always, you can download these exact notes in the link below, and stay tuned for another math easy solution.